Hello everyone, we are Team Tri-Tek and we are going to present the Oliver property. My name is Buba Sako.
I'm Jennifer Todd.
Spencer Kidd. Tony Caruso.
Okay, so we are going to show you a flying, so this is the outline of our presentation. That's pretty much what we're going to talk about. And next we are going to show you flying to our site. We have a technical problem right here.
Well, our site is located right near the District of Columbia. It's about 10 miles away. It's also located right near Tyson's Corner for anyone who's familiar with the area. Here we have Tyson's Corner in a big orange bubble, so you can see it. But right, the little rectangle is our site, and right to the south of our site is another shopping area. This one has the grocery store, the Kmart, the things that you would normally on a day-to-day basis go to. And also near our site we have schools, we have places of worship. It's really near everything you would need for a residential site, so it really sort of points to that use, and it's also zoned that way. Additionally, just off to the north of our site, we have all the utilities you need for a residential site. We have electric lines, gas lines, sewer. You can read. We were told two main objectives by our client, that they wanted to preserve the character of the surrounding community and that they wanted a high lot yield. So we designed one layout that really focused on each of these. Preservation of character had fewer lots, but they were bigger. It had less road. It had a cul-de-sac, but the other one had an intersection, which is more expensive. They both had about the same amount of green space, and they both had their good points. One minimized earthwork, the other maximized lot density. We went with preservation of character. We felt that it would be easier to get people to buy a quality lot than get a lot of people to buy a less quality lot. But they would be paying for that quality at almost $300,000 per lot, just in development costs, preliminary cost estimate.
The topography on the site was the main issue, as you can see. We have steep slopes on the north end of the site. The rest of the site is pretty hilly. Our choice for the entrance of the road had to be from Georgetown Pike because the road, this road right here, Pine Hill Road, is a private road and we weren't allowed to access from that. As you come into the development, we have a sag curve in the beginning to deter any kind of ponding and to eliminate any water that would flow across Georgetown Pike. After that, we tried to achieve a vertical slope of 10%. And we also try to conform with the existing topography to minimize any earthwork. The grading was pretty tedious on this site. As you could see earlier, there are a lot of high value slopes. We had some challenges here in this dog leg. Our site cuts a corner right here, and our maximum cut and fill was 3-to-1. We had some issues right here trying to make sure that we tied into existing before we went off site. We did have some steep slopes here, and we tried to mitigate that with the two retaining walls that we put right here. It tried to conform to a better site characteristic and really helped with the slopes in between those two sites. Otherwise, we'd have very steep slopes and almost no usability there. We did have a lot of cut volume on this site, mainly because of the entranceway, as you could see on the profile view that Spencer was talking about. We did have a really deep cut at the entrance to the site, and that kind of paved the way for the rest of the site, where we had to come up from that everywhere to get to our existing lots, and then come up even more on the edges to get to our existing. The offsite entrance restrictions that Spencer talked about, including we didn't have any legal access to the road to the west, so our only entrance was Georgetown Pike on the north. And there is an existing intersection, Mackle Avenue, on the corner, in the northwest corner, and we had a traffic restriction. We couldn't be within 300 feet of that intersection, so that pretty much told us we had to come in somewhere around this area. And the tie-in slope restrictions did cause a lot of cut because we couldn't do any more than a 3-to-1 fill. So you can see all this goes pretty far back with that slope. And then Boob is going to talk about the stormwater management policies.
Okay, so the storm sewer layout was actually the first one to be designed because we have so many restrictions in order to make it meet the pond on the northern part of the site, and it actually affects the layout for the sanitary sewer and the water pipes. However, the storm sewer pipes are affected by the grading, and that is the reason why we have two separate pipe networks. On the western side of the eastern side of the road, and one smaller network on the northern side of the road. And also, as you can notice, we have 3 pipes running across private properties, and so we are probably going to need easement for those pipes. And the reason for this design was because it is the most cost-effective option, because having the pipes run across the road would require a lot of manholes, and one manhole is about $3,000. And the storm sewer pipes and the pond were actually designed for a 10-year storm event. And this is our pond. It's a shallow, dry pond. And the reason we have decided to go with a dry pond is because a wet pond is not feasible for a project of this size. And so pretty much most of the time, the area is going to look like a grassy field, and this is also going to add to the aesthetic of the site.
The other 2 wet utilities that we designed for were the sanitary sewer and the water line. Like the storm sewer, the sanitary sewer is gravity driven, and we didn't use any pumps. The design occupancy was based on 4 people per unit at a rate of 100 gallons per day with factor safety of 4. The water line is based on a fire flow, which is basically a peak flow to allow for adequate pressure throughout the site, and it's pressurized and not gravity driven. And as Jen said before, there are existing dry utilities. There's a gas main and overhead electric surrounding the site, further supporting the notion that this site is feasible for residential use.
All right, so ENSC Phase 1 will be put into place before any construction begins. We do have the construction entrance that will be put in place on the onset of the construction. We do have silt fence around almost all of the site, along with a tree protection line that runs along a drip line of all the preserved trees, which will help to eliminate any root damage from any of the machinery on site. And we also have several diversion dikes that will redirect excess runoff from the steeper slopes on site, and they direct to 1, 2, and 3 sediment traps that are used to slow down the flow of water and help let the sediment settle out. And temporary seating is put in place for any location that has been disturbed but is not being graded for in excess of 30 days. And then ENSC Phase 2 will be put into place once the permanent stormwater management facilities have been put into place, and the diversion dikes and the sediment traps will be removed to facilitate the permanent grading plan. The construction entrance, silt fence, and tree protection will all remain on site until the end of construction. The culvert inlet protection will be put in the south corner, where we do have a 100-foot pipe extension, because we will be filling in 100 feet of the existing stream. And the permanent seating will be placed at the end of construction to facilitate the soil stabilization.
Every project has a cost. We use the unit price schedule to get our cost multiplied by quantities. We were also asked to get some price reduction options, including we found that street lamps cost about $4,000 up there, so we could try and reorganize, get rid of one of those. But the reason we didn't use these options in the final site was because we thought that the site that we had created had the best character preservation for the site, for the surrounding area. So that is why we went with the site that we did.